So I'm going to let u equal the thing that's inside the 4 function. So du will be e to the 3x times 3. So let's think about this. So the e to the 3x, so that's, 4 to the e to the 3x. That gives me 4 to the u, right, by putting the u in there. So let me think. I've got an e to the 3x and a dx I need to take out. Oh, there it is. There it is. So if I replace those with a 1/3 du, 1/3 du, pull the 1/3 outside, you know that the antiderivative of 4 to the u is 4 to the u over ln of 4 plus c. And then I put the x's back in. 4 to the u, 4 to the, I meant to put the x's back in. 4 to the e to the 3x over ln of 4 plus a c. Okay, let's do this one. So again, I've got this number to exponent, so I'm going to let u equal the inside of the exponent. So du, you know, is negative cosecant squared. So I'm going to break this up. So I get 5 to the cotangent times 1 over sine squared dx. So I can see that the u goes inside of the 5 function, 5 to the power, right? So this gives me 5 to the u, right? And then what about that? Well, you look at that. Don't you know that 1 over sine squared is cosecant squared? So I can say negative du is cosecant squared of x dx. So I put a negative du, pull the negative outside. You know the antiderivative of 5 to the u is 5 to the u over ln of 5 plus c. And then put the x's back in. So cotangent over ln of 5 plus c. Let's look at this one. So I'm going to let u equal the inside, u equal the inside of the cosine function. So du, chain rule, right? dx. Okay. So this is the same thing as saying cosine of e to the negative x times 1 over e to the x dx. Okay, so then I'm going to put the u in, so I get cosine of u times, wait a second, can't I rewrite this? If I rewrite this, putting the negative exponent in the denominator, isn't this the same as saying negative 1 over e to the x? Right, that negative here puts it in the denominator. It's almost there. Negative du is 1 over e to the x dx. So negative du. Okay, I know that the antiderivative of cosine and sine carry the negative along,